and some memorization techniques for solving problems, this can often happen. What happened? Did the rules change? We're just adding fractions. The rules all changed. A lot of times students have been learning basic operations for a few years even, since kindergarten, and they've never seen a fraction. So when they come to fractions, they think, wow, the rules changed. The rules didn't change. And by the way, what we're going to show you here is just one of the methods we have for teaching fractions. And some of the pieces that we use for fractions. We use other manipulatives also to teach fractions. What if I use this? What if I use this algorithm? Which is just I use that word, it's just all that's a fancy word. All that is a fancy word for problem-solving technique. Let's see here. I'm going to multiply this one times that one, and that one times this one. And then I'm going to multiply this times that. Oh, wait a minute. Yeah, and then I'm going to add these guys together. Wait, I multiply this times that, and then I add those two together, and then I multiply these two together, and of course I come up with 5/6. Seen classroom situations where this is the way it's taught. Whoa, let's see, and they even have the little arrows in the textbook. This is no help. What we have is concept number 2, where what we're going to do is count things that are same. So let's get a basic understanding of what these fractions mean. All right, what we have here are some fractions tiles. And what I want to stress is that this is only one of the ways that we can explain fractions to children. Now, do you see here I have 1 and I've made it bigger so I can manipulate it and we can talk about it. There's 1, but now here's 1 broken into 2 parts. And here's 1 broken into 3 parts. And of course we could break it into 4, 5, 6, 7, 8, 9, etc. Now, let's see. Further I can go here and see that I have actually 1 of 2. It would take 2 of these to make this. In other words, it's half of this. And here I have 1 of 3. How do I write this? Need some symbols. 1 of 2 parts. 1/2. This is the numerator. It tells me how numerous. This is the denominator. The denominator, the name of it, tells me what kind. So here I have 1 of the halves kind. Here I can show 1 of the thirds kind. And if I had 2 of them here, of course I could say I have, how numerous is it? Well, this time it's 2 of the thirds kind. So let's get back to our problem. What I had was 1/2 plus 1/3, and I wanted to know how much I had. And to make it more real and tangible to the students, let's tell a little story. The story is very simple. I have a box of cereal, actually 2 boxes of cereal. One is half full, and the other is a third full. And I want to put them together. Now for little kids, we can just ask the simple question, if I put a third and a half together, will I have enough room in the box? Take it a step further, if there is enough room in the box, how much do I have? How full will the box be? Well, here's a half and here's a third, and we need to understand that fractions, like you and I, don't like to wear the same clothes every day. In fact, sometimes they like to wear disguises. Now, here is 1/2 with no disguise on, but now I put a disguise on. Here is 1/2, but now it's 2 of 4. But you see, it's still just 1/2. Now it's 3 of 6, but it's still just 1/2. Equivalent fractions. Here is 1/3. We can do the same with 1/3. 1/3 is the same thing as 2, 1, 2 of 6. 1, 2 of 1, 2, 3, 4, 5, 6. And when you get larger, you can see that we can also teach skip counting and multiplication using these fraction tiles at the same time as we're teaching fractions for the very young students. Now, let's see. Because I'm pressed for time, I'm just going to do this. I know, because I have some experience in mathematics, that I want 6th kind. We can develop that with the students. And once again, because I'm doing this very quickly in an overview, fractions alone, we could spend 2 hours teaching fractions on a tape or on a DVD. Anyway, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, we've got same kind now. We have 3 of the 6 kind. And you can even see if I flip this around that these pieces are exactly the same. They're exactly the same size. And again, this is only one of the ways we teach fractions. Here I have 2 of the 6 kind. Now that I have same kind, remember concept number 2, we only count things that are same, I can see that I have the same kind here. 3 and 2 is simply 5 of the 6th kind. And we can see that it would fit in a box. Because the box isn't full, it's 5/6 full. So that's how we get 1/3, or excuse me, 1/2 plus 1/3 is the same as 5/6. And what we did is we just multiplied by 1. And when we get to the algebra, this will be very important to understand. Right? Instead of all those arrows, we just multiplied this by 1 to get 3 of the 6 kind, and multiplied this by 1, 2 over 2 is the same as 1, to get 2 of the 6th kind. It's 5/6. We make this simple and easy for the children to understand. And this, I took a slight leap here, but all we're doing is showing clearly and concisely fractions. Now, one thing that I've had happen to me on more than one occasion is I have teachers ask me, well, how come when you multiply fractions, they get smaller, and when you divide fractions, they get bigger? Because it seems that in regular numbers, if you do division, the numbers get smaller. And this shows a fundamental misunderstanding of what we're doing. All we're doing is counting. And in order to make these ideas clear to you, you'll have to watch another training video where we do fractions. But certainly it's not the fault of the teachers. If they've been taught this way, and the people that taught them have been taught this way, they might get confused as to why when you multiply, things seem to get smaller. Nothing gets smaller, we're just counting. And when you do division, things seem to get bigger. But nothing really gets bigger, we're just counting. Here,